Alright, welcome back. Happy Friday the 13th. So if you're not at school today, or maybe you need a little bit extra help, remember that this lesson was on Friday the 13th and we're on page 9 of the notes. Okay. So the last 2 days we went over ionic bonding and we went over, does anyone know? Hydrogen bonding. Very good. Okay. So now we're going to talk about covalent bonding. So if you're on page 9 of your notes, I want you to write as the header, covalent bonding. Okay. So covalent bonding, can anyone tell me? Good. Yes, sharing of electron pairs between atoms. Okay, so we're going to personalize that, put that into our own spin. We're going to try to get a little scenario to figure out how that works and how we can relate that to the real world or just for it to make sense in our head. Okay, so first, like always, what we're going to do, we're going to take an atom. Okay, when you have one atom, you put them together, you get a molecule. Okay, so can someone tell me, they know off the top of their head from middle school, what is the chemical formula for oxygen? Beep, boop, beep, boop, beep, boop. Correct. Good. It is O2. So O2 is just when one oxygen atom and another oxygen atom come together and you get O2. Okay. So we use oxygen every day. We breathe it in, it goes into our body. We use it for cellular respiration. We breathe out CO2. And day on and day out, we're continuing to do that. Very important part. So first, what I want you to do, I want you to go find oxygen on the periodic table. Where is it? Let's look. It is on the second period in group 16. So oxygen, let's write it down right here. You can write along with me, okay? Excuse my O's. Looks like ovals, but we'll make it work. So what's the atomic number for oxygen? 8. And we know that from looking at the periodic table on the left side, right there, left corner, you got an 8 atomic number. Now, atomic weight is how much the atom weighs. Okay, remember it's not in pounds. It's measured in a very, 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 very small microscopic mass. Okay, so we have 15.99. Now, we're going to write P and an E. That just stands for protons, neutrons, and electrons. Okay, so how many protons are in oxygen? Good, 8. And we know it's 8 because protons are the same as the atomic number. Okay. Neutrons. So for neutrons, you're going to take the atomic weight, which is 15.99, and subtract it by 8. So 15.99, is that closer to 16 or closer to 15? Very good. It's closer to 16. Like it's 15.9. You want to look at the number after the decimal. If it's higher than 6, you're going to round to the number ahead. If it's lower, like 4, 3, 2, or 1, you're going to round to the other number that is lower. So for example, we're going to go, since it's 15.99, we're going to round up, and we're going to go 16. So what's 16 minus 8? Very good. It's 8. Going back to elementary days. All right. Electrons. Remember, electrons are negative, protons positive. So protons are 8, electrons are going to be 8 as well, with the negative version of that. Okay. So now we have this. I'm going to erase this. I'm going to pause the video for a second if you need to write it down. But I'm going to erase this and I'm going to move on. Okay. Perfect. All right. So now we have oxygen and oxygen, which makes up O2. So we're going to talk about how these two bond together because it's different than ionic bonding and it's different than hydrogen bonding. Okay. So we're going to take our one oxygen molecule and we're going to draw it. So what goes in the nucleus of an atom? So remember, these Bohr models, or if you just took a microscopic, very, 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 very zoomed in look at an atom, this is what you would see. Okay, so that's a real world, what it would look like if you were looking at this. So in the middle of an atom is this thing called a nucleus. It's really heavy, it takes up a lot of space. I mean, it takes up a lot of weight. What are the two things that are in the nucleus? Correct, protons and neutrons, okay? So let's draw our little nucleus. And on the inside, it's going to be P equals what? How many protons do we have in oxygen? Very good. We have 8. How many neutrons? 8 as well. Look at us. Moving on. Okay. Now, we are missing the electrons. The electrons are not inside the nucleus. They like to hang out. They're the ones at the party that hang out on the outside. Okay. They don't like being in the middle of it. They're on the wall, bouncing back. Okay. So, a little nervous. So, you're going to draw electron rings to represent the electrons on the outside. So how we do the electron rings, remember. So the first ring we look at period 1, there's only 2 electrons, or atoms. So we know in the first electron ring, there can only be 2. But we need a total of how many? 8. So let's just draw the first ring. And we know that we need 8 in total, but we know this one ring only fits 2. Okay? So what we're going to have to do next is draw another ring. But the other ring is a little bit different. If you look at the second ring, we have 1, 2, 3, 4, 5, 6, 7, 8. It can fit 8. So, the second ring, let's draw another ring. I'm trying to draw a little bit neater. Okay. Following. Okay. So we have 1, 2, 3, 4. How many do we need? We need 8, right? So we have 1, 2, 3, 4, 5, 6. So now in total I have 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I have 8. Right? Let's draw another oxygen atom. Okay? So it's going to be the same thing. So you're drawing the same thing you drew here. You're going to draw adjacent. Okay? So we got the P equals 8. N equals 8. And 2 electrons here. Outside we have 6. 1, 2, 3, 4, 5, 6. Okay. So remember how we talked about how the outside layer, in order for it to be happy and content and chilling at the party, it wants to have 8. It wants to be full. But if we look at these oxygen atoms, let's count the electrons in the outer ring. 1, 2, 3, 4, 5, 6. It only has 6. How many does it want again? Good, it wants 8, okay? So both these only have 6. But they want to bond together. They want to be content. They want to be happy. They're trying to find, someone at the party to dance with or something like that. So, what's going to happen here? Remember we talked about covalent bonding. And covalent bonding, do you remember it was defined as the sharing of electrons between atoms? Sorry, the sharing of electron pairs between atoms. So do we see any pairs here that maybe want to match up tonight? Or match up in this situation? Yes, we do. So we needed 8, right? So covalent bonding is the sharing of electron pairs between atoms. So if we look here, there's one pair right here, one pair right here. Look what's going to happen. They're going to bond together. And so when they bond together, let's count now. Okay? So we have 1, 2, 3, 4, 5, 6. And remember, they're bonding, so 7, 8. So this one has 8. Let's count this one. 1, 2, 3, 4, 5, 6, 7, 8. And this one has 8. So they shared their pairs of electrons. And when they did that, their outer layer now had 8. And they're complete. They're fine. They're chilling. They're relaxed. They're all good. And this is how we get a covalent bond, also known as an oxygen molecule, which you use to breathe in every single day. All right, if you have any questions, remember come to Coach class Thursdays, 3 to 4:15.